Okay, welcome back. There's going to be another video on complex numbers again. We're done with the conjugate root theorem now. So this is a question that comes up sometimes on patterns in I. So don't call it that. That's just kind of what I'm calling it. So I, like we know. So I, obviously, is equal to the square root of -1. That's our complex number. So just about patterns when you square it and cube it and put it to the power of 4, basically. Okay. So I'm just going to write them out. I to the power of 1 is just equal to I. Yeah. I to the power of 2, I'll use a different colour, or I squared is equal to -1, and that's because I'm going to write this over here. I squared is equal to I by I, which is equal to the square root of -1 squared, and anything squared and the square root of at the same time is just equal to whatever is inside it. So that's, if you stick that into the calculator there, you'll get -1 as your answer. Okay, so I squared is -1. Now I cubed, I'll go blue. Okay, I cubed is going to be -I. I have to scroll down a little bit for this. So I cubed is equal to I by I by I. So a better way of writing that would be I squared by I. And since we already know that I squared is -1, we can just say that's -1 by I. And now just to finish it up, that's equal to -I. Okay, so hopefully that all makes sense. Yeah, and now the last one, then I'll go this color here. I to the power of 4 is going to be equal to 1. Okay, and then I'll explain that. So I to the power of 4 is equal to I by I by I by I, or I cubed by I, and I cubed is -I multiplied by I. Okay, so I cubed is -1 is -I here, and then so we're just kind of summing that in here. So that's going to be equal to -I squared, because -I by I. Okay, and I squared, we know, we go up here, is equal to -1. So it's -1, which is equal to 1. Okay, so here's our 4 numbers there. So now the trick is basically, or they ask you, okay, how do I say it? Yeah, the trick is basically, it just keeps rotating like this. So I'm not going to work these out, but I to the power of 5 is equal to I to the power of 6 is equal to -1, I to the power of 7 is equal to -I, and this pen is fidgety, I to the 8 is equal to just 1. Okay, so if you see they're the exact same as, I can't get them all on the same screen, but I to the power of 1 is the same as I to the power of 5, I squared is the same as I to the power of 6, I to the power of 3 is the same as I to the power of 7, and I cubed is the same as I to the power of 8. So basically just repeats on this cycle here of these 4. Okay? And that's a trick we can use to solve any kind of I problem. So they can ask us, so the example I use, if they ask us to find I to the power of 27. So obviously you're not going to just keep going and following that rotation again and again and again. It'll take forever. Or you're not going to multiply them all out. That'll take forever as well. So what you do is you divide 27 by 4. Okay, so 27 by 4 is going to be equal to, sorry, no, it's not equal to 3. It's equal to 6. Okay, because 4 goes into 24 6 times. Remainder 3. Yeah, so the remainder is going to be 3. Okay, so that means that I to the power of 27 is the same thing as I to the power of 3. Yeah, and if we just go back up to our table here, so these ones you can just work out, it doesn't take too long. I to the power of 3 is -I, so I to the power of 27 is equal to -I. Okay, so it doesn't get any bigger or smaller. No matter how high the power is, it's still going to go just one of these. It doesn't get bigger or smaller. It goes I -1 -I, or 1. It's going to be one of these 4. Okay, and that's just kind of a quick question you can do if they ask you to calculate something that's really, really high. You can just do this. So if it's remainder, I'm just going to, so I to the power of 27. Okay, we get rid of this and all of this. excuse me. So that was I to the power of 27. For example, if it's I to the power of 24, we're going to go 24 divided by 4 is equal to 6, and there's no remainder. So that means that basically I'm just going to say no remainder. The answer is going to be I to the power of 4, which is just 1. Yeah, and that's the only kind of difficult one. If you try this problem and there's no remainder, you might get confused. Then it's just I to the power of 4, which is equal to 1. So any of the other ones, if there's remainder 1, it's going to be just the first one. It's going to be I to the power of 1. Yeah. If it's remainder 2, it's going to be this one. Remainder 3 is going to be this one. And if there's no remainder, then you have this answer here. Okay. So I hope that's helped, and there's a nice little trick for calculating I.